Hello, welcome everybody. Welcome to the Black History Month virtual lecture series done in partnership with Berkeley County Schools and Jefferson County Schools. My name is Tanya Dallas Lewis, and I am the Cultural Unity and Equity and Staff Development Coordinator for Jefferson County Schools. And I'm so happy to be here tonight as we get ready to steam ahead in excellence. Dr. Walker?
Good evening, everyone. And as a representative for Berkeley County Schools, I'm the Associate Superintendent for Equity and Inclusion. We are excited to partner with Jefferson County Schools in this initiative for Black history, steaming ahead in Black excellence. Tanya, I'll turn it back over to you.
Great. We're so excited because we understand that Black history is American history. And so with this lecture series running from February 3rd to March 3rd, we are going to feature a guest lecturer. And tonight, to be introduced by my son, that's S-U-N, Dylan Sampson Alexander Lewis. He is a 9th grade student in Berkeley County. And Dylan, come on over and do the honors. Tonight, we'll be highlighting STEAM, as STEAM stands for science, technology, engineering, arts, and math.
Hello, my name is Dylan Lewis, and as she already told you, I'm a 9th grader in Berkeley County, and I will be talking about Dr. Joseph L. Graves, Jr. Dr. Joseph Graves, Jr. received his PhD in Environmental, Evolutionary, and Systematic Biology from Wayne State University in 1988. In 1994, he was elected a Fellow of the Council of the American Association for the Advancement of Science. In 2012, he was chosen as one of the Sensational 60, commemorating 60 years of the NSF Graduate Research Fellowship Award. In 2017, he was listed as an outstanding graduate in biology at Oberlin College and was an Innovator of the Year in U.S. Black Engineer magazine. His research in the evolutionary genomics of adaptation shapes our understanding of biological aging and bacterial responses to nanomaterials. His book on nanomaterials is entitled Antimicrobial Nanomaterials, Principles and Application, Amsterdam and E. Elsevier, publication fall 2021. His books on the biology of race are entitled The Emperor's New Clothes, Biological Theories of Race at the Millennium, Rutgers University Press, 2005, and The Race Myth, Why We Pretend Race Exists in America, Dutton Press, 2005. With Alan Goodman, Race and Racism, Answers to Frequently Asked Questions, Columbia University Press, 2021. He leads programs addressing underrepresentation of minorities in science. He aids underreserved youth in Greensboro via the YMCA chess program. He has also served on the Racial Reconciliation and Justice Commission and COVID Vaccination Task Force of the Episcopal Diocese of North Carolina. And now, Dr. Joseph L. Graves.
I want to talk to you tonight about African Americans in my discipline, evolutionary science. As you may be aware, I was actually the first African American to ever earn a PhD in my field in 1988. But I was shortly followed by my good colleague, Dr. Scott Edwards, in the middle panel, who is now professor of evolutionary biology at Harvard University. And the gentleman to the right, Dr. Paul Turner, is a professor of evolutionary biology at Yale University. And 2 years ago, he was elected as a member of the National Academy of Sciences, which is the highest honor that any American scientist can ever earn. So, before I begin talking about my own work and some of my life, I'm going to give you a brief history of African Americans in higher education. Now, most of you probably do not know that chattel slavery was instrumental in founding the first American colleges. So in an excellent book by C. Wilder called Ebony and Ivory, Race, Slavery, and the Troubled History of America's Universities. It documents how the trade in enslaved Africans actually generated the capital that was necessary to build most of the first universities on this continent. Now, before the end of the institution of chattel slavery, few African Americans earned college degrees. Now, the notable exceptions to that were at Oberlin College. Now, when I went to Oberlin in 1973, I actually had no idea of its abolitionist history. It was founded by the Lane theological rebels, who were literally run out of Cincinnati by a lynch mob for their abolitionist views, and they escaped with their lives to later found Oberlin College in the plains of the Chance Creek River in 1833. Now, the college was founded on the principles of learning and labor, and it was the first American college to admit female students on an equal standing with male students in 1833. 2 years later, the college voted to admit African American students in 1835, and two of Oberlin's students, John Copeland and Sheraton Leary, were killed in John Brown's raid at Harper's Ferry. So in 1837, Cheyney University was established in Philadelphia by the Brotherhood of the Quakers. In 1851, the University of the District of Columbia began to educate African American women. In 1856, Wilberforce University was established in Ohio by the African Methodist Episcopal Church. In 1865, Clark Atlanta University was established by the United Methodist Church. In 1866, Fisk University in Nashville, Tennessee. In 1868, Hampton University, which graduated Booker T. Washington. In 1890, the second Morrill Land Grant established multiple historically Black colleges and universities, including the one where I am currently a faculty member, North Carolina Agricultural and Technical State University. Now, in the Morrill Land Grant of 1890, or in this map, we can see both those that were founded in 1862, and many of these are universities that you automatically recognize, such as the University of Florida, the University of Tennessee. And then in 1890, most of the historically Black institutions, such as North Carolina A&T, South Carolina State University, and so on, were founded by the Second Act. So now, it should surprise no one that these original historically Black colleges and universities were not entirely founded with the goal of bettering the situation of persons of African descent in the United States. In fact, much of what they were designed to do was to control the struggle for equality and justice of persons of African descent in the United States. And so early on, there was an intellectual struggle between various leaders to determine where historically Black institutions should go and how they should do it. So in one of my favorite essays written by W.E.B. Du Bois, who was actually the first African American to graduate from Harvard University, he writes, "Unless the American Negro today, led by trained university men of broad vision, sits down to work out by economics and mathematics, by physics and chemistry, by history and sociology, exactly how and where he is to earn a living and how he is to establish a reasonable life in the United States or elsewhere, unless this is done, the university has missed its field and function, and the American Negro is doomed to be a suppressed and inferior caste in the United States for incalculable time." So in this essay, Du Bois was arguing against the vocational school model which was fostered by Booker T. Washington for the historically black colleges. In other words, Du Bois argued that these colleges needed to teach science, technology, engineering, mathematics, sociology, and not train people to be seamstresses and carpenters. So this is a quiz. And since, we're not in person, last time I gave this lecture, we were actually in person. I'm going to give the question and give the answer too. So, what year was the first PhD awarded to an African American in biological science? And who was that person? So the answer is Alfred O Coffin, who was born in 1861. The date of his death is was not determined. There's considerable controversy about when he actually died, which is why the question marks are there. But he received his PhD in zoology at Illinois Wesleyan University in 1889. Now, again, at this time, most of the historically black institutions did not have PhD granting programs. And so if one wanted to pursue a PhD, you had to leave a historically black institution and go to a historically white institution, in which many of them in the North allowed students of African descent to enter those institutions at the PhD level. For example, Ernest Everett Just, one of the greatest African-American biologists of the early 20th century, received his PhD from Dartmouth College. So, you already know the answer to this. What year was the first PhD awarded to an African-American in evolutionary science, and who was that person? Okay, so that was me from Wayne State University in 1988. Now, the point that I'm making here is that the first generation of African Americans in evolutionary science are still alive. Some of us are a little older than we'd like to be, but we're still here. So Scott Edwards, Paul Turner, and others. So to have a sense of how I got to that point, one needs to go back to my early education. I went to school in 1960, and this was only 6 years after Brown versus Board of Education integrated American public schools. Now, throughout the American South, that integration, because as the court said, with all deliberate speed, but with no metrics or mandated activity, this took a lot longer in the South, the former Confederate states, than it did in the North. However, when I entered school in Westfield, New Jersey, it was assumed that Negro or colored children were inferior, and we were all tracked into slow learning groups. They considered me a behavior problem. And in fact, my mother had to go to the school often based upon complaints about my restlessness in the classroom. Now, the simple fact was that I finished my work well ahead of all the other kids. And so if you could imagine, a 6, 7, 8-year-old little boy who's bored out of his mind because he finished his work 30 minutes before everyone else, that child is likely to become a behavior problem. So this changed on a fateful day in 3rd grade during library time. Most of the other children were reading books like Fun with Dick and Jane. I was reading the book on the left, Harold Lamb's university level textbook about the Crusades, Iron Men and Saints. So a student teacher sat down next to me and asked a question that none of the other teachers had ever asked, because they assumed that I had these big books out because I was showing out because I actually couldn't read. But she sat down and she asked me the question, "Little boy, what are you reading?" And then I proceeded to give her a history of the First, Second, and Third Crusades, all the major events, all of my favorite characters in this series of historical events, and the woman was mortified. The next day, I was transferred into the advanced learning groups. And that, they say, was history. Another big event in my early years was learning how to play chess. Now, again, I was in third grade. I came to school one day and some of the older kids were playing chess before going into the school building. And so, curious as I was, I walked up and I said, you know, can you teach me how to play? And so they taught me how to play in a few minutes. And of course, I played a game against one of those older kids and they beat me mercilessly in that first game. So that afternoon during library time, I went to the library. I got several books out on chess, went home, and that night under the covers with my flashlight, because when mom said lights out at 8 o'clock in my house, it was lights out at 8 o'clock. So I used to read by making a tent with my flashlight and reading my books at night after everybody else had gone to sleep. And so I read Bobby Fischer's book, Bobby Fischer Teaches Chess, in one evening, went back to the schoolyard looking for those same kids that beat me the day before. I sat down and beat them mercilessly. And soon after, I was the school's chess champion. By the time I was in junior high school, I was our junior high school chess champion. I began playing with the Westfield Pawns at the local YMCA, which was a competitive chess team. By the time I was in high school, Westfield High's chess team was #1 in the state, and I played third board. This picture in the right is literally from our our high school yearbook from 1973. We went to the national championships and came in, out of 500 teams there, we came in the top 20. And literally my game determined the national championship that year. So chess was crucial in my intellectual development because it taught me how to think ahead and to envision things in my mind that you don't see in front of you. And these were essential skills which I then deployed in the development of my scientific career. And by the way, I am still an active chess player. This last weekend, I played in the U.S. Amateur Team Chess Championship, which, you know, maybe the only one good thing that COVID has brought us is that chess tournaments now are all conducted online. So I could play in the U.S. Championship on the West Coast. And we came in 9th out of 35 teams. In the final round, we played University of California, Berkeley's team that ended up winning the entire tournament. So anyway, if your schools don't have chess clubs, I strongly recommend that you implement them. Now, if you read my biography, I've been involved in teaching chess to elementary school and middle school children in Greensboro for the last 15 years. And we've seen great strides in terms of student productivity in schools that have chess clubs. So I cannot overemphasize how important it is to start chess clubs in your schools. Now, to have a sense of, you know, who I am in the Pantheon of Science, this is a genealogy of the scholars who were mainly responsible for producing me. At the top of the tree, basically this tree of my intellectual mentors in the past generations starts with people on the left-hand side who come from my fruit fly genetics background. One of those people was Thomas Hunt Morgan, the Nobel Prize winner in the 1930s, who demonstrated that genes were found on chromosomes. On the right-hand side of the diagram is my evolutionary biology pedigree, and I'm descended from one of the greatest theorists in the history of evolution, Thaddeus Dobzhansky, who said nothing in biology makes sense save in the light of evolution. His student was Richard Lewontin, who was the leading population geneticist at Harvard in the 1960s and 70s, who gave rise to my intellectual grandfather, Brian Charlesworth, who I know Lewontin and Charlesworth personally. I never met Dobzhansky. He died before I was in graduate school. And then my postdoctoral mentor, Michael Rose, who I was on with right before giving this talk in a seminar that we were doing in genetics on the West Coast. And then me and some of my students continuing this legacy below me. So how did I do my PhD and what problem did I work on? I'm one of the people who actually demonstrated that genes control aging. Now, you may think that, well, that's obvious, right? Genes control most everything that happens in an animal's body, animal, plant, or any other organism. But you might be surprised to know that in the 1980s, even though we thought that genes should control these aspects of an organism, no one had ever proved it. And so I was on the team. In fact, I'm the only person in the world who's worked in the first two laboratories to experimentally postpone aging. And essentially what that means is we change the pattern of aging of an animal. My postdoctoral mentor, Michael Rose, did it first in 1984. My PhD advisor, Leo Luckenbill, did it later that year, literally months apart. Now, what was really interesting about these flies that lived much, much longer than their ancestors was that they showed superior physiological performance. And again, that might make a lot of sense, but no one had measured that until Phil Service did it in 1985. Now, Phil Service discovered this by complete and total accident. When I began working on my PhD, I reasoned that one of the reasons that these flies could live so much longer than their ancestors was because their physiological system had changed. And the best way to measure the physiological system of a fly is to measure how long and how fast they fly. So to do that, I had to invent a method. And this was an example of, real simple reasoning, but simple reasoning that led to a very profound result. And I read in the literature that fruit flies, when they're lifted in the air, have something called the tarsal reflex. And they think that they need to fly. And so this is something they won't stop doing. So I simply took very light test fishing line, and with a drop of Duco cement, very small, and the reason this worked, by the way, is because Duco cement, and I hope nobody from the Duco company is in the audience, but Duco cement isn't really a very good cement. And so I could put it on the fly without harming the fly, and the fly would fly until it was exhausted. So I was able to show that the flies that had the extended lifespan also were able to fly 6 times longer than the ancestral flies with the short lifespan. But the next question was, well, maybe these flies are flying longer because they're flying slower. So I had to invent a machine to measure the instantaneous wing beat speed of the fly. So I contacted a colleague of mine in the physics department, and we built an optical tachometer, which allowed us to measure the flight speed instantaneously. And that led to my first publication in the Journal of Insect Physiology on flight duration and wing beat frequency and long and short-lived Drosophila melanogaster. And in it, I showed that not only did these postponed aging flies fly longer, they flew just as fast as the ones that could only fly 30 minutes compared to 3 hours. Now, when I became a professor in the field of evolutionary biology, I began to study reasons why students choose particular disciplines. And in a very important paper we published in the journal Evolution, Education, and Outreach 5 years ago, we looked at factors that could influence how underrepresented minorities could be retained in a scientific field. Now, key findings of that study were that there were differences between underrepresented minority groups in their understanding and interest in evolutionary biology. We also found that the presence of role models was important to African Americans and Mexican Americans, but not so important for Puerto Ricans. Now, that makes sense if you realize that Puerto Ricans come from the island of Puerto Rico, where their doctor, their lawyer, all the professionals they see are Puerto Ricans who look just like them. In the United States, where African Americans and Mexican Americans live, there's a dearth of those people in professions. So therefore, role models more important in African American and Mexican American communities, but not so important to Puerto Ricans. We also found that African Americans harbored greater levels of evolutionary misconceptions and had higher levels of religiosity than other groups. Now, before I go on, I'm going to make it very clear to the audience that I am a confirmed Episcopalian, very active in my church. I'm very active in the Episcopal Diocese of North Carolina, working on several commissions appointed by our bishops. I find absolutely no contradiction between my faith and my science. Now, unfortunately, the history of the United States has been one where some religious denominations continue to find ways to create a false contradiction between religion and science. I completely reject that. Now, one of those false views is the idea that human beings evolved from monkeys. That's absolutely false. Okay, but this is a common misconception. Humans and chimpanzees share a common ancestor that was neither a chimpanzee or a human. Okay, we did not evolve from existing chimpanzees. And so one of the things that we found in our work is by helping students understand these scientific misconceptions about how evolution works, it actually improves their capacity to learn it. Now, another misconception that appears and has been problematic is the idea that science says that persons of African descent are genetically less intelligent than persons of European descent. I've spent a great deal of time demonstrating that it is absolutely false. I was one of the first people to demonstrate that the book, The Bell Curve, was based on all sorts of false assumptions and, in fact, poor statistical reasoning. Now, that led me to write 2 books on this topic. And if you're unfamiliar with them, The Emperor's New Clothes is a history of racial thinking in the Western world. In other words, how did we come to think this way, and what's wrong with thinking that way? The race myth assumes that you know the history of how we came to think this way, and then demonstrates the ongoing pathology or mistakes in reasoning that result from thinking racially. Now, both of these books were written in 2005, and so recently with my colleague anthropologist Alan Goodman, we've done an update. So this book, Race and Racism, Answers to Frequently Asked Questions, will be coming out from Columbia University Press in the fall of 2021. What's updated in this book is that when my books were written, the Human Genome Project had just really begun. And now we have over 15 years of sequencing data on human genomes. And that information is now incorporated in my discussion in Race and Racism, Answers to Frequently Asked Questions. So now, how can we make progress? First, we must ask the question, why do we want to see the demography of science change? Well, there are moral and ethical reasons. It's just the right thing to do. However, I say it's more than that. Does science get better with different cultural perspectives brought to the table? My answer to that is absolutely yes. For example, the neutral theory of molecular evolution resulted from the fact that Moto Kimura was from Japan and had thought differently about the data than people from England and the United States. So the long and short of it is, the more cultural perspectives we have looking at scientific problems, the more readily we can find mistakes and biases in the way we think about that problem. Now, 2 years ago, I held a meeting at the annual Biomedical Research Conference for Minority Students called Abercroms, and this was in Indianapolis in 2018. There were over 4,000 undergraduate students who were primarily underrepresented minorities: American Indians, Puerto Ricans, Mexican Americans, African Americans. There, I had held a workshop spotlighting the next generation of leaders in the field. So students learned why and how evolution is relevant to biomedical research. Students were exposed to underrepresented minority scientists who were conducting cutting-edge research in the field. And students learned why the core mechanisms of evolution are central to modern biomedical research and clinical practice. So these are all people that I have had relationships with and mentored at various portions during their career. I'm particularly proud of my most recent PhD student, Dr. Sade Boyd, who began her postdoctoral appointment at University of California, Los Angeles earlier this year. So that's the end of my presentation, and I'm happy to address any questions that the audience might have.
So thank you, Dr. Graves. That was very enlightening. I learned so much. At this time, we want to open up our Q&A. So if you have any questions for Dr. Graves, please populate your chat box in the chat, and we will forward those questions to him. I had a question while people are thinking it up. Just before I ask my question, I want to let people know what's coming ahead. So we're going to do about 10 to 15 minutes of Q&A with Dr. Joseph L. Graves. And then we're going to have a student spotlight by a Berkeley County student by the name of Zora Muhammad. She is actually doing the STEAM Student Spotlight, where she highlights, and every week we'll have students coming on to highlight actual students who are in science, technology, engineering, arts, and math right now as young people. But here's my question for you, Dr. Graves. Mm-hmm. First and foremost, wow. Second, what can we as educators do? Well, let me say this, as a mom and as an educator, I know that our children are natural scientists. They are inquisitive, they want to touch, feel, know, and explore. So how can we encourage, especially the populations who aren't typically going towards science? What can we be doing as educators to get kids involved in science?
That's a really good question, and I completely agree with you. Children, all children, start out naturally as scientists. It's part of the way our brain is wired. We want to learn things about the world around us. We want to observe things. We want to draw general conclusions. And unfortunately, there's a great deal of scholarly literature that shows that the way that we're currently educating children educates that inquisitiveness out of them. And that has to change. So what is needed is a curriculum that focuses on critical thinking, as opposed to memory and rote repetition. Okay. Another thing that we need to do is we need to allow children to have self-esteem bolstered by academic achievement. Now that might sound sort of crazy that that's necessary, but in the transitions that have occurred in the US society over the last couple of decades, okay, it is no longer cool to be smart in school. I can give you examples of where my son, who is now a PhD student in applied mathematics, people would come up to him and slap books out of his hand, making the argument, oh, are you trying to be, quote, white? And we have to change that worldview where intellectual activity and accomplishment is viewed as no longer something that should be conducted by persons of African descent or any person who wants to learn more. So here's an example. I'll give you one more example before we go to the next question. So that same child that I'm just talking about, when he finished his high school in Greensboro, he was the #1 rated math student in the state of North Carolina. So you would think that we would have been recruited by the University of North Carolina. Okay. Now he had over $2.8 million in scholarship offers, but not a single dime from UNC Chapel Hill. Now I know if my son were the #1 basketball recruit in North Carolina, Roy Williams would have been at my house every night. Now he ended up going to Duke because Duke recognized his talent. And I told him, I said, you know, you're not going to a private school unless they give you a scholarship because dad is not paying private school costs. And Duke came and Duke gave him a huge scholarship. So again, it comes down to what do we recognize? Chess clubs, okay? Chess clubs recognize intellectual talent, okay? And puts that intellectual talent in competition, okay? Science clubs, math clubs, instead of being viewed as, you know, social things you want to stay away from and socially ostracizing people, the school district needs to play those students up. Okay, Friday night in North Carolina, we have a show, Friday Night Lights, in the fall. All the football teams, okay, are played up. Why don't we have a Friday night chess, Friday night science, Friday night math, so that the school district is showcasing the kids who are doing intellectual and academic work. So it comes down to what do we value? If you value football and basketball, then what do you think kids are going to want to do? They're going to go to what's valued. If you value intellectual achievement and you show that by your school's priorities, then you're going to get more kids wanting to follow that way of being a student rather than going into athletics.
Great points. Thank you, sir.
Dr. Graves, we have several questions that are in our chat, and I will read the first question to you from Linda. Toward the end of your presentation, you mentioned the importance of including various cultures. Could you please repeat your statement? The more cultural perspectives we have looking at a problem, the more readily ... She wants you.
The more readily we can find the biases in the problem, in the way the problem has been researched, and the more readily we can look at new perspectives of how to solve that problem. Now, I'm going to give you a really good example. And again, I'm hoping not to insult anybody from the pharmaceutical industry, because I work very closely with two rather large pharmaceutical concerns whose names will remain off the show. But how we approach disease depends upon certain sets of values. If you think the way to deal with disease is invent a drug, give the drug to the person, and fix them after they're sick, that leads to a certain sort of research program. However, if you think that the best way to lower the incidence of disease is to have people maintain healthy lifestyles, exercise, clean water, clean food, okay, lowering the exposure to toxic materials, okay, and prevent disease to start with, then that's a completely different research program. So it depends upon your worldview and your perspective. So the more people we have with different ways of examining the world, the stronger our capacity to come up with correct solutions to problems becomes.
Thank you. Another question that we have are there any concerns for African Americans regarding high levels of melanocytes and the safety of COVID vaccines?
Okay, so I serve on the COVID vaccination task force for the Episcopal Church in North Carolina. Back in oh gosh, it's so long. Back in 1997, I wrote a series of papers on the false biology of melanin. There are a number of African Americans who have presented scientifically inappropriate and incorrect ideas about the way melanin works in human skin. And I explained in my papers why that was all wrong. And so when it comes to how a vaccine works, it has absolutely nothing to do with the level of pigmentation in your skin. Absolutely nothing. Okay. I have followed the Moderna vaccine, the Pfizer vaccine from their very beginning. And for folks in the audience, I want you to know that one of the primary scientists responsible for the Moderna vaccine is Dr. Kitzmetzia Corbett, an African-American woman who received her PhD at UNC Chapel Hill and is now one of the directors of the National Institute of Allergy and Infectious Diseases. And the reason I say that is because there's a great deal of vaccine hesitancy amongst African Americans that is based on a lot of misinformation and superstition, and the idea that there are no African American scientists. In fact, African American scientists have played a key role in the development of all of these vaccines from the very beginning. So the idea that, somehow the vaccines are going to harm African Americans is absolutely wrong. And to give you the tragedy here, I wrote a piece for Science for the People magazine at the very beginning of the pandemic. And if you noticed, I was on Roland Martin Unfiltered 3 times at the beginning of the pandemic. And everything I predicted back in March and February of 2020, happened. Everything I predicted happened. And what we're seeing now in North Carolina is a colleague of mine is a physician at Duke's University Hospital. He says the COVID ward is filled with Black and brown bodies, people dying from COVID 2019. The vaccination line is filled with persons of European descent. Because the way we are distributing the vaccine in North Carolina, persons of European descent are twice as likely to be able to get a vaccine as persons of African descent. So my statement here, and I've said this on the news, on Fox News, in Atlanta, all over the country. If you can get a vaccine, you need to get it as soon as you possibly can. COVID 2019 kills people. There are now over 32 million people who have been vaccinated. There's only been 1 death out of 32 million people. The rate of death of COVID, if you do the calculation, it's close to 2 to 3 out of 100. So for every 100 people who get COVID, 3 people die. So do the fraction, 1 over 32 million versus 3 over 100. So get vaccinated. And unless we get vaccinated, unless there is mass vaccination, the situation is going to get worse, not better. Now, these new, more transmissible, more dangerous variants, I told Roland Martin back in February 2020, that unless we got the transmission of COVID under control, we would soon see the evolution of more dangerous COVID variants. So understand, the higher the number of infected people gets, the more dangerous this becomes. And also be aware that COVID 2019 is only a level 3 pandemic. If you think about it like hurricanes, COVID is only a level 3. The 1919 influenza was a level 5. We don't want to get to a level 5 because that influenza killed everybody. So vaccination is our only way to survive this.
Thank you. Another question is, what is one contemporary scientific subject that I can promote in my middle school art classes that you think will propel them and excite them?
Wow. So there's so much stuff, because first off, nature is just beautiful, right? And we'll go back to viruses, right? I was at the Joint School for Nanoscience and Nanoengineering. We have a helium ion microscope manufactured by Zeiss that's capable of seeing down to the width of 3 helium atoms. So we can image things like viruses and bacteria. And they're absolutely beautiful. So one of my colleagues, by the way, who is a microbiologist, she is an artist. And she draws pictures of these microbes and displays their characteristics and structures. So there are so many things in nature, even the simplest things you see every day, like leaves and trees, okay, or ants. If you look at them under a microscope and look at their structures, they're absolutely amazing. And so students interested in art, have at it.
Perfect. Thank you. Then I think we're going to do one more question, Tanya, if you're okay with that. And then we will forward the questions and see if he would be able to answer, Dr. Graves would be able to answer the questions and get a response for you. Because we want to give an opportunity for our superintendents who are present to also have any closing remarks if they so choose, after we show the spotlight for our student, Zora. The next question is, I wanted to ask more about telomeres and how they impact our lives each day.
Okay, so telomeres are the ends of our chromosomes. So for people who aren't scientists, all animals have what are called chromosomes. And these are strands of DNA that are interwound with a set of proteins called the histones. On the DNA molecule that is associated with a specific chromosome, at the very end is a sequence of nucleotides, and the nucleotides are the adenine, thymine, guanine, cytosine, ATCG. That region is called the telomere. Now, the reason this is so important is because, I work with bacteria, and bacteria have a circular chromosome. Let me see if I let me see if I have the tools to draw here. I don't think you gave me those tools. I can't draw stuff. So they have a circular chromosome, and the enzymes that replicate the DNA can go around in a circle and they don't have any problem, right? Because it's a circle, they just keep going. In our chromosomes, they're a straight line. So when the replication machinery comes to the end of the line, it doesn't know where to go. So an enzyme called telomerase comes in and it builds a loop. And then the replication goes around the loop and then goes back in the other direction. So essentially it makes a circle. But that loop has to get cut off. That's the telomere. And so what happens is every time your DNA replicates, the telomeres get shorter and shorter. And so they become a measure of your aging. So young people have long telomeres. Old people like me have much shorter telomeres. Now, what we've been finding, and what's really interesting here, is that the level of stress that an individual goes through in their life more rapidly destroys their telomeres. So, for example, women who have taken care of chronically ill children, their telomeres are much, much shorter, and they show 8 to 10 years worth of aging compared to women of the same age. We also know that institutional racism shortens people's telomeres and results in causing them to age faster than they should. And so I've been working on this problem of the differential lifespan of African Americans in the United States for now 30 years. And one of the things that shows how racism kills people is it's shortening their telomeres.
Very nice. Thank you for sharing the information and answering those questions for us, Dr. Graves.
Well, thank you again for having me.
Yes. So at this time, I know there's more questions, and I have some questions and comments myself, but we're going to have to move on and honor the time. We've got Zora Muhammad. She is a senior at Martinsburg High School in Berkeley County, West Virginia. I had the pleasure and honor of being her teacher when she was in the 7th grade. She is currently in the women's choir, the show choir, the National Honor Society for Music, and was recently selected for All National Choir. She will be attending West Virginia University to study music education. And so, with our steaming ahead in Black excellence student highlight, here is none other than the special, amazing, intelligent, and talented Zora Muhammad.
Hi, I'm Zora Muhammad, a senior at Martinsburg High School in Berkeley County, West Virginia. And today is your Black History Month lecture series, Student Highlight, with a focus on science. 3 Black teenage scientists in 2018, 17-year-old juniors, Michaela Sheriff, India Skinner, and Bria from Banneker High School in Washington, D.C., identified a problem that they needed to solve. These 3 young ladies created a way to purify water in school drinking fountains that may be contaminated by lead. How did they do it? By using copper shards, drinking straws, and filter floss. They tested and even tasted the water. The rudimentary purifier works. The 3 friends became one of the 8 teams that were finalists in a NASA competition to apply space technologies to earthly challenges. For your Black History Month lecture series, Student Spotlight for Science, I'm Zora Muhammad, steaming ahead in Black excellence.
And Zora had to work tonight, so she wasn't able to be with us live, but we're looking forward to having a number of students on each of these live virtual lecture series, and they're going to be sharing some wonderful things. Dr. Walker?
At this time, we wanted to give an opportunity for our superintendents of Berkeley and Jefferson County Schools to make a comment if they so choose to do so. I will start with Dr. Patrick Murphy and then Dr. Bondi Gibson, if you wanted to take an opportunity in a moment to speak to us this evening.
Thank you, Dr. Walker. This is Pat Murphy, superintendent here in Berkeley County Schools, and I want to extend a big thank you to Dr. Graves for your leadership and also passion for science and sharing it this evening with us. You are the kickoff speaker of a series of 5 evenings that we're going to have, and I want to make a special thank you also to Dr. Walker and to Tanya Lewis for putting this event together this year. A special shout out to Dylan, your son, Miss Lewis, for a wonderful introduction of Dr. Graves, and to Zora, who can't join us, but we'll pass along well wishes to her for what she brought to this evening's event. Dr. Graves, I think you made some wonderful points. I've heard the emphasis around chess throughout my career, and it's kind of restored a new interest in maybe establishing a stronger foothold in there. But thank you, sir, very much for kicking off our series. And if you're the start, we only have greater things to look forward to. Thank you, Dr. Walker.
Thank you. Dr. Gibson.
Oh, thank you so much for the opportunity. I would echo Dr. Murphy's sentiments in thanking everyone for taking the time. And Dr. Graves, in particular, I think that your comments regarding the shortened telomeres were fairly profound at such a difficult time. I swear, I think mine are nubs now that you've now that you've pointed that out. So many things come clear to me now. But if there is some grace in this whole situation, it's that we've been spurred to do some amazing, innovative things like this Zoom session, like this series, and I think that if there is any group that is better equipped to find the light in any difficult situation and to hold it up for the ones who come behind them, it's definitely this group. So thank you very much for letting me be a part of it. I appreciate it.
As a forum, thank you, both superintendents. Thank you so much for being here. It speaks volumes for you all to be here on the kickoff night. That is totally awesome. As we prepare to close, I just wanted to make one final announcement. Next week, turn to your neighbor and say, next week, next week, next week, next week, we will be doing this again. Same time, same place, 6 to 7 p.m. And of course, our STEAM focus will be technology with Dr. Lauren Augustine. So I'm really excited about her joining us. We'll have 2 more students, but this time live, to feature and focus on some students in STEAM. I also wanted to make a shout out on behalf of HISTA, the Health Science and Technology Academy, known as HISTA or HSTA. It's a one-of-a-kind mentoring program in the state of West Virginia that helps underrepresented high school students enter and succeed in STEM-based undergraduates and graduate degree programs. So we are looking to hopefully have a representative from HISTA the next time. Shout out to all the 8th graders, because you all are eligible to join, and I'll have more information coming up soon. You can reach out to your school counselors, or of course to myself in the Culture, Unity, and Equity Department, or as well to Dr. Veronique Walker. I'm done. Do we have any closing comments from you or our featured lecturer?
I will make only one quick comment that if there are any questions I did not answer, feel free to send me an email at my university address, and I'm happy to answer those questions for you.
And we will also make sure that we make that email address that you're speaking of available to our district so that they can reach out to you. Thank you so much, Dr. Graves, for taking time out of your busy schedule, because you are a very important person to be here. So thank you. Thank you so much.
Thank you, and have a great evening, everyone.
Good night. Stay safe, stay warm, stay healthy.